in which we talk more about functions. So here's the button grid design version 2 with a new function included, init buttons. So the code to reset the buttons was originally duplicated across both setup and mouse clicked, so this is an obvious candidate for a new function. If we want to do something more than once or in more than one place, then putting it into a reusable component makes total sense. So here we've separated out the resetting of the buttons into a separate function, which we call init buttons for initialized buttons. So the flow of information setting or reading the button states is shown by the blue arrows here, and the calls to functions are shown in green, so here, here and here. Okay, so for example, when the mouse is clicked, the system calls the mouse clicked function. And we can see how init buttons can write to the button states, and it can be called from a number of different places. So when setup needs to initialize the buttons, it now calls init buttons. There's no code to actually explicitly initialize the buttons in setup, it's all done here. Importantly, mouse clicked can also call init buttons when the reset button is pressed, and this separates out that functionality so that the main conceptual job of mouse clicked is to deal with the buttons that can be flipped, but the reset functionality is still implicitly captured by the fact that it can also initialize them by calling the init buttons function. And here's the code to actually implement this. So we've defined a brand new method, init buttons, which is void because it doesn't return any value, it simply acts on the array of button states. We still need to use the brackets here to denote that it's a method, even though it doesn't take in any input, any parameters. So whenever we need to use it, we simply call init buttons, as we've done here, as it's essentially been added to our library of functions. And here we use it again in the mouse clicked function. Apart from allowing for reuse, we can see how using understandable names for our functions makes our code largely self-documenting. We can see just by looking at what this bit of code does, what its actual function is. It initializes the buttons. So by allowing us to replace lots of code with a shorthand call to another function, we make our code much easier to understand as well as more efficient. So this code is in the weekly code zip file for this lecture in reset buttons init method, and I suggest that you pause the movie and take a look at it now. So thinking about this code, which you hopefully have up in processing, are there any other places where we have to do the same thing several times, the same sort of thing in multiple places? Pause the movie, have a look at the code in Blackboard, on Blackboard if you haven't already. Have a look, think about this question, and then come back. Well, when mouse clicked is called, we check where the mouse pointer is in two different places. One for the reset button, here, and once each for the individual buttons, here. In both cases, we're essentially comparing the mouse X and mouse Y to different ranges. The ranges are different, so the ranges here are defined by reset X and reset Y, the height of the reset button and the width of the reset button. Here they're determined by the size of the button and the location of each individual button, but essentially the same job is being done in two different places. The fundamental question we're asking is this point encoded as a set of X, Y coordinates inside this region, encoded by an X, a Y, a width and a height? If it is, we do something. If it isn't, we don't do something else. So this generic question, is a specified point inside a specified region, seems to be quite a good candidate for separating out into a multi-use function, as it can come in useful in a number of different places. So the proposal is that we create a point inside function which takes in a point and some information about the region and returns true if the point is inside the region and false if it's outside. So here's the block diagram for this particular function. Pause the movie and attach labels to each of the arrows going into and coming out of the function. So this function takes in 6 pieces of information and it returns 1 piece of information. But what are the labels attached to each of these arrows? So this function takes in 6 pieces of information. It takes in the x and the y of the point and 4 numbers representing the region. The top left hand corner of the rectangle of the region, the x and the y, the width of the region and the height of the region. And it returns a single value, a boolean. It returns true if the point is inside the region and false if it's not. And here's the code for this function, and I've shown a graphical representation of the different variables in play here just to show how they work. So these are the parameters, the information that we pass into the function. So the function returns a boolean, either true or false, so we need to specify that here in the function declaration. It's not a void function. Okay, then we specify the inputs to the function, okay, the parameters. These are basically local variables that exist only so long as the function is being called. They can't be used outside the function. They don't exist outside the function. But they allow us to process the decision based on the values that are passed into them. Okay, so this is an abstraction of the specific 2 examples of where this is done in the app. We can pass in different values representing different points and regions, and the function will give us the answer in exactly the same way. And this is important because it now allows us to very easily, in a sort of general purpose way, ask whether any point is inside any rectangular region. And this means that we can very easily add buttons and so on to our app, but also use that sort of functionality in lots of other different applications without having to explicitly repeat the region checking code for every single button and every single comparison that we want to make. Okay, so here we have the parameters. Okay, so we can pass in values into the function, and they're assigned to these temporary variables, and then we basically just say if the point x is greater or equal to the region x, and the point x is less than or equal to the region x plus the width of the region, and the point y is greater or equal to the region y, and the point y is less than or equal to the region y plus the height of the region, then yes, it's inside the region, and we return true. Otherwise, we return false. So here's the new version of the code which I've put up on Blackboard as reset buttons point detection, and you'll notice how instead of checking the location of the mouse pointer with long-winded repetition of effectively the same code, with minor tweaks we simply call the same function with either constants representing the region of the reset button here, or variables representing the region occupied by the current button that we're checking, the bottom example. So again, I hope you can see how doing it in this way makes the code much shorter and more elegant, but it also makes it much easier to understand. So if you look at this section here, you can almost intuitively see that what this is saying is if the mouse x, mouse y, if the mouse is inside this region, then we initialize the buttons. So really, the code is almost self-documenting. Now if you notice this line of code here in which we check the result of calling the point inside function, here we're using the return value in an expression rather than assigning it to a variable. So we're basically phrasing it like it's the equivalent of saying, does calling this function result in a value that is true? So if we say if point inside and then the parameters, that's essentially the same as saying if the result of calling point inside with these parameters equals true. And this is just shorthand really. So let's just go over again how we create our own functions, because I think it's important. So any function is either void, it returns nothing as in the init buttons function, or it returns a value. So a function might take in, say for example, a student number, access the database, and then return the surname of the student. In this case, it might take in a string of digits and return a string of characters representing the surname. Another function might take in a temperature in one scale, say Celsius, and convert it to Fahrenheit. So the inputs and outputs are both floating point numbers and so on. So here we're asking a question: is this thing true or false? So in this case we return a Boolean. Here we specify the name of our function, and the same rules apply as when we name variables. You can't have spaces, they can't start with a number, and so on. The important thing is to pick short but meaningful names so that your code is easily self-documenting, as we've already seen. And these are the parameters, the information that we pass into the function. As we said earlier, they only exist so long as the function is being used. They disappear when the function completes. They're local to that particular function. So when you call a function, you must give it precisely the parameters that it's expecting, the right number of inputs of the right type in the right order, otherwise the system will give you an error. If it's expecting 6 integers, you need to give it 6 integers, no more and no fewer. And here's the body of the function in which we operate on the parameter values that were passed in, make a decision and return a value. And you'll note that the use of the curly brackets to denote the body of the function. And here are the return statements by which we pass information out of the function. So every function that's not void needs at least one return statement which returns a value that is of the same type as the return type specified in the function declaration. So we can return any type at all, not just Booleans. Once a return statement is made, then the function immediately terminates. So here we say, basically, if the point is inside the region, then immediately return the value true, otherwise return false. Here's the temperature converter that we mentioned a while ago. The formula from Fahrenheit F to Celsius C is as follows. We subtract 32 from F, then multiply the result by 5/9. So in this case, F is the input. As temperatures can have a decimal point, we use floating point variables, which are represented by the float data type. So it returns a float and it takes in a float, F. Okay, we can then directly return the result of performing the calculation. We don't need to store it in a temporary variable within the function. We can simply say return the result of performing this calculation. So here we see an example of how we capture the output of the function. So we might create a variable f, which we call 54, which is not the same f as this one here. Remember, this is a variable that is local to this function. Okay, it only exists within this function. Outside, this is a different variable. Okay. So we create f as a float, give it the value 54, and then we can say here, create another variable, which is a float c, which takes the value of calling the function Fahrenheit to Celsius with the value f. Okay,